Today we are going to play Snake, but not any Snake. We are going to play Snake 512, which we will modify to load from the VGA BIOS of our ViRGE DX. But that's not everything. We will also look into making our text splash screen dynamic to show the actual frequency the BIOS is set to. Now, before we get into all of this, I want to mention two things. First, I participated in a podcast over at golem.de. This is specifically for my German viewers. So if you want to listen to 1.5 hours of Martin and I talk about old PCs and 3D graphics, head over there. The link to the podcast is in the video description. And second, there is a new tool available for S3 cards, S3 Control, started by RetroLoom. So if you're looking for another tool that can fix your pedestal bit, well, maybe have a look at this tool. He's still looking for information and test results, so if you want to contribute, check out the project. It is still quite new and under development. Check it out, link is in the video description. The first thing we will tackle today is the dynamic text splash screen. In a previous video, we overclocked the ViRGE DX, but what bugged me is that the text splash screen remained static. So when you post with my card, at the end of the text there is M70. This card is running at a stock frequency of 70 MHz. So M70 is definitely the megahertz reading. Now my card runs at 77 MHz, but it still displays 70. I want to show the actual frequency. And of course that means we will use Ghidra again, do a little bit of patching the BIOS, and use code snippets that I will share on my website, but also on s3virge.com. So if you want to use any of these things, you should be able to find them quite easily. S3virge.com was set up with the help of Porkbun and specifically for all those S3 related projects. Porkbun is a domain registrar and it's honestly refreshing to see things done quickly and right to the point. There are no annoying upsells like, oh hey, here are another bazillion domains you might like, or don't forget to pay extra for basic security. At Porkbun, who is privacy for keeping your personal information safe and SSL certificates for site security are just part of the deal with every eligible domain. But the biggest reason you should look at Porkbun is basic honesty. Instead of luring you in with fake discounts and then doubling the price on renewal, Porkbun sells most of the domains at cost. The renewal price stays the same and it is always shown clearly before you complete your order, so your cost stays low and entirely predictable. Managing your domain is super simple with their clean web interface. And if anything ever goes wrong, you get access to real human support every single day of the year. So it is no wonder that Porkbun is top rated by Forbes Advisor and USA Today. The link to porkbun.com is in the video description, and if you use my promo code, you will get an extra $1 off your next domain at porkbun.com. And now, let's continue with today's projects. And here we are already in Ghidra, and we are trying to make a dynamic text splash screen that shows us the frequency that the card is clocked at. I will not go into every single detail again, so if you want to get more information, watch my previous video on how to add an image splash screen to your BIOS, because I will use Ghidra there as well. And in that video, we also looked at the text splash screen that is right at the beginning of this BIOS file, because that text shows us where we have to look in the code to show the image splash screen. But today, we want to modify this one. And you can see here we have generic BIOS information. This is our S3 ViRGE DX chip, BIOS version 1.01.03, and we have EDO M70. So we have EDO memory and we have M70 for, well, megahertz, I guess, 70. So this is what we want to change. Now we need to find again the place where this text is accessed, and this is at address 45. So we can simply search for this. So it is 0045. So this is the address of our text, and we have, I think this one here, moving to register SI. I think this is where the text is accessed. And yes, I believe this is the function. So in here we are storing the address of our text, and then we are calling this function here that most likely displays the text on the screen. So yes, this is the location we are interested in. Now, instead of calling this function directly, I want to call another function that modifies the text first before we then call this function to display it. So this is the goal. I want to make a new routine that basically overrides the two numbers 70 with whatever is encoded in our BIOS file at memory location, I think C2 and C3. This is also mentioned in my overclocking video of the S3 ViRGE. Now, of course, we're not going to write this by hand. I already asked Claude Code to help me out with this. And here is the assembly code. So on the left side, step 1, 2, and on the right side, step 3, this is all just computing the value of the actual frequency of the card. This is basically reading the values of N and R from address C3. We're also reading value M from address C2, and then the code computes the actual frequency of the card. In step 4, 5, and 6, we clean up the numbers, do some rounding, and prepare them to be displayed on screen. And in step 7 is the actual patch. This is when we override the values of our BIOS. And this is basically the code that I will copy and paste now, and then we will link it to our existing methods. This is the hex code of the assembly code that we have looked at just now. So this one we have to add somewhere. And now we need to find an empty spot somewhere in our BIOS file. Now this BIOS was extended from 32 to 64 kilobytes, but the second half of the chip is full with our image data for the image splash screen. So we have to find something before that. So the chip basically ends here, the 32 kilobytes ends here at 7FFFF. And from here onward starts our image splash screen. So we have to go somewhere before that. And I think I will start here at 7C00. So this one here looks nice. Yes, we could start earlier, but I will just put it here now at 7C00. This is then easy to reference when I need to call this method. So let me just quickly clear this. And now I can just paste this code. Let's decode it. Yeah, here we see C3. This is our N and R value. Here is our M value. And then here at the end, we are writing, you even see some comments here. We are overwriting 7. I guess this is the 7 part. It still references 70 and shows the rest of the string. But then here, this is the second digit, the 0. And we just write 1 digit, override it basically. And this is it. So our method is now in the BIOS, but it's not yet called. Now we need to figure out where to call it. And our method is at 7C00. Before we looked at 0045 and it was here. And basically what we want, instead of displaying it, we first want to call our method to modify the string and then call 4834. So we need to patch this instruction. Instead of calling the original method, we have to go to our method, and then our method has to call this method. So then let's patch this instruction, and instead of 4834, we go to 7C00. This is our new method. Now we should come to our place. Yes, so this is what we just copied into the BIOS file. This is the routine that overrides the text. And here at the end, I already have the call back to our 4834 function. So now we continue where the original code would have ended up at. And this is it. Now the only thing we have to do is we have to change our checksum. And now let's see what the card displays when we flash this BIOS. Checksum is okay. Do we see 77 now? Yes, M77. Great. So our text splash screen is now dynamic. Let's just go quickly to MS-DOS. MCLK, the tool that we have used extensively in the overclocking video. And this one tells us we are running at 76.96 megahertz. So our BIOS reports the correct values. And this routine that we added in the BIOS was extracting these numbers that you see next to the frequency here, M41, N2, R1, and it applied the formula that is written underneath. So now let's go quickly to my website and let's change the frequency to something else. Maybe something like 65. Let's try 65. Okay, here's my website, and here you can go to S3 ViRGE BIOS Toolkit. And here at the very bottom, we have the S3 ViRGE BIOS Overclocker. Here is our BIOS that we just saw in action, and you can see the same frequency here right now. And now we said, like, let's try maybe 65. So 65, we can use, we want to go for a low value of N. This is, I think, what we said last time. So I'll try, no, this is 64. This is This one should actually show 64. This one should say 65. That's because of rounding. So let's try this 71, 2, and 2. The nice thing about this is now I can just download the patched BIOS. I don't have to do anything else. I'll get the new BIOS with a new frequency and the correct checksum. So we don't have to do anything. I can just flash this directly. And let's see if we see now 65 on the text splash screen. Yes, there we go, 65. So yeah, this code is now completely dynamic and it shows the actual frequency that is configured in the BIOS. Okay, great. 65.33, we got 65 on the text splash screen, all perfect. And we got the correct numbers as well, M71, N2, and R2. Okay, great. So this is the first part of this video. Now let's continue and have a look at Snake. And what we are specifically looking at is Snake 512. This is a boot sector size Snake game, so it is less than 512 bytes, the entire code. So we can go here into assembly and we'll see the code here. This will be interesting later on when we try to change the colors, because for instance, let's say background color here, this one here is a variable, but it will be encoded inside the code, and you can see that we have it appear once, twice, 3 times, 4 times. So it's referenced 4 times in the code. And this is because some of the game logic is using the color, trying to figure out, is the game over if you hit a wall or if you bumped into the snake's tail, for instance. So I just want to make this point that the game logic depends on the colors, not on coordinates or something like this. Okay, then now how do we get this code into our BIOS file? Well, you cannot copy and paste it. I had to take this code, put it through Claude Code, and then tell it what to do, that I want to run this from a VGA BIOS. Here is the code of Snake 512 adapted to work on a VGA BIOS. I'm not going to show you the assembly code with the comments that we did for the dynamic text splash screen. It's just too much code, and you have the Git repository that is almost identical to what is here, at least the game. There are some minor changes, but we'll see this once this application is running from the VGA BIOS. Then let's get this code and put it into an empty space in our VGA BIOS. So here is our dynamic splash screen. This is already something that we have added. And then we have some empty space from here. So yeah, we have to make sure that we're not going over 8000. This is where our image splash screen starts. Then let's paste our Snake code here. And this is it. So now we have our code goes till 7F5 till here 5B. But we have to reference it. So this is again a dead code block that is not being called right now. I want to show the Snake game after the image splash screen, but before the text splash screen. So if you remember from the previous video, we started at offset 8000. This is where our image splash screen function starts. We just have to shift this entire thing a little bit more down. We need 3 extra bytes here. Let me just do it that way. I'll just duplicate this function call, but then we'll change the method call to our Snake game entry. Let's take these 4 bytes and I'll just write them in here. Okay, now we should have 2 times the same. One method call will not make any sense right now. Let's decode this again. So yeah, this one here doesn't make any sense because this relative address doesn't work anymore. So we patch this function, restore it to the previous one, which was 03. We have to get rid of this offset here. Okay, now this is done. And now this method we have to patch and call our Snake game. So patch instruction. And this was at 7C70. I think this is our entry to Snake. It's a sub function now. Let's see. Yes, this is where we started. 505351. Okay, I think this is it. So right now our image splash screen also runs the Snake game. Now let me change the checksum and let's see if this game works. And S3 ViRGE Snake. And this is something that I have added. So this is basically a timeout. If you don't press anything, the boot process will continue. But now let's press N to enter the ViRGE Snake game. So Snake, N, and here we are. There is no sound, unfortunately. Probably it can be added through PC speaker, I believe. But there are limitations. For instance, if you're using a USB keyboard, you will not be able to control the Snake. But yeah, here is Snake. This is Snake 512, adapted to run from a VGA BIOS. If you're trying to do this with anything that accesses a MS-DOS function or something like this, it will not work. So you need programs and applications that are written to use the very basics of a PC. That is why a boot sector game is something that works quite easily because they are written to run on BIOS functions. Okay, let's change the colors. Okay, now we're back in Ghidra. I already made some bookmarks. So here is everything that's important right now. So we have here a border color, a snake head color, background colors. Here is the snake body, food, and here's some logic. Let's have a look at the border. Right now, this is dark green. This is encoded here in assembly. Now, what does BE mean? For this, we have to quickly look at the VGA color palette. So there is a default color palette that is accessible when the BIOS starts executing. I'm not really sure where this color palette is stored. Let me and us know in the comments if you have more information. But yeah, so this is the border and it is set to BE. So what is BE? Here is the color palette, and the color palette is arranged in 16 by 16 squares, which gives us a total of 256 colors. So that also means we can address each color with 1 byte. So for instance, if I want to have the first color on the top left, this is 00. If I want the color in the bottom right, this is FF. So the higher bits or the left side of our byte is deciding which row we select, and the right side or the lower bits decide which column we pick. So if I want, for instance, the color red, I have to pick 0 because this is 0 denominated. I have to pick the first row, so 0 for the row and 4 for the column. So 0, 1, 2, 3, 4, also 0 denominated. So this is our color red. Now what I want to do is I want to change our color codes to something like this, for instance. So this would be another version of Snake, just a different color theme, so to say, but we use the same color palette. We just have to reference different colors. Armed with my bookmarks, this shouldn't be too much of a problem. Here are all the addresses that need to be changed. So I'll just do a few of them and then we can imagine that the rest follows a very similar approach. But let's do a few of them together. So here is our background. This is BE. Now, if I want to have it in dark blue, I need to get 86 in there instead of BE. So we can just change this and I'll change this now to 86. I can decode this again and now we have 86 going as a color for the border. Let's do the snake head. Snake head right now is set to 12. I want to change this to 77. So let's clear this and let's change this to 77. And like this, we can go through the entire file. As I noticed I made a mistake. It's just a number flipper. So this is 68, not 86. This was a mistake. I noticed it when I added the checksum. Let's see if we have Snake now in the color blue. Yeah, here we go. So now we have also looked at a color palette. How cool is that? A default VGA color palette and how it is referenced from that game. Okay, and I think this is it for this video. Let me know what you think about this. And I obviously hope that you enjoyed today's video, making a text splash screen dynamic and adding a game to the ViRGE BIOS. Who says the ViRGE can't play games? And of course, also, if you haven't subscribed to my channel, I would be really happy if you would do so. And then I want to thank Porkbun for sponsoring today's video and you for your time and watching. I also want to thank everyone who is supporting Bits and Bolts over at Patreon and here on YouTube. If you want to support the channel, please head over to Patreon or become a member right here on YouTube. And I hope I will see you in my future videos. Take care and bye bye.